Start, sir.
Okay, thank you. Is it clear?
Yes, sir.
Okay, right. Okay, welcome back to our webinar classes, students. Good morning, one and all. So we are going to discuss second class of hyperbola. So now that's in the first class we have discussed what is the hyperbola definition and the standard form of hyperbola and the remaining that one. So transverse axis and the conjugate axis. So in the previous ones, ellipse and the parabola, we are discussed as major axis, minor axis. But in the hyperbola, we are discussing that transverse axis and the conjugate axis. Okay, now, so we have to do some problems in this one about this yesterday previous concepts. That one first to find the equation of the hyperbola of a given length of transverse axis is 6 whose vertex bisects the distance between the center and the focus. Okay, question. Find the equation of the hyperbola. We have to find the equation of the hyperbola. That is, I'm taking x square by a square minus y square by b square equal to 1. If a is greater than b is a different formulas. A is less than b, it will be different formulas. So then, so length of the transverse axis. So which means I'm taking of this one is the length of the transverse axis. I'm taking the a here a dash. So this length is given that is 6. So vertex is bisects a distance between foci and center. If you center, it is here, and the focus I'm taking here, I think. So this is S, this is C. So this vertex bisecting this C and S. So then we have to find the equation of the hyperbola. So then for that one, solution, let the equation of the hyperbola I'm taking x square by a square minus y square by b square equal to 1. X square by a square minus y square by b square equal to 1. Then, so let C be the center of the hyperbola. A is a one vertex. I'm taking A is one vertex. S is the corresponding focus of the hyperbola. S is the corresponding focus of the hyperbola in the previous one. I draw that one now. So then I'm taking C here, and this is a vertex A here. So this is if I'm taking S here. So then these three are that one. Next, given length of transverse axis, this total length of the transverse axis is equal to 6. In the question is given that length of the transverse axis, that is length of the transverse axis, if A is greater than B, that is 2A. So that is equal to 6. From this one, 2A equal to 6. So then we can, then now given vertex bisect the distance between center and foci. So given vertex, this vertex bisect these two one. So this is bisects of what? CA equal to CS. So here CA equal to CS. Just it's doing CS bisecting by A with the same distance. So then, so 2A equal to CS. 2CA, sorry, 2CA equal to CS. So then, so we know that CS value is A. CS value, it is nothing but focus. CA value, length of the semi-transverse axis. So that is CA value. So just substitute 2A equal to AE. 2A equal to AE. 2CA equal to CS. Then 2A, this CA value is A, and this value is, I'm substituting A, and CS value is AE. So then E equal to, I will get E value. So here A will get cancelled. I will get E equal to 2. So E equal to 2. Then next I get E value 2. Then I have to find B value. So for that one, in the this way, from this one, A equal to 3, we can get A equal to 3. A value is 3. Okay, so just find for B. Find for B, that is B square equal to A square of E square minus 1. This is hyperbola, I'm taking b square equal to a square of e square minus 1. Then just a value. So a value, we know the value of a, that is 3, and the e value is 2. Just substitute there. A value is 3 and e value is 2. Substitute there. B square equal to 3 whole square of 2 square minus 1. 3 whole square of 2 square minus 1. Then this value 3 square is nothing but 9 of minus 9 of 4 9 of 4 minus 1. Then we'll get b square equal to 9 of 4 minus 1, that is b square equal to 9 of 3. B square equal to 9 of 3. So that is b square equal to 27. B square value is 27. That is b equal to root 27. I'm writing 27 as root in the root 9 into 3. 9 multiplied 9 3 is 27. So under root, which is, so root 9 value is nothing but 3, and root 3 is root 3, writing. Okay, so b value is 3 root 3. And equation of the hyperbola. So just equation of the hyperbola, what we are taking, that this one. So x square by a square minus y square by b square equal to 1. Then a value is 3. Then just substitute value a equal to 3. Then a square value is 9, and the b square values will get 27 value. So just substitute in the required equation. That is x square by 9 minus y square by 27 equal to 1. This is a solving. Okay. Now next theorem. So most important and a repeated question for IPE. So the difference of the focal curved distances from any point on the hyperbola is constant. So the difference of the focal curved distance of any point on the hyperbola is constant. So focal curved means, in the previous ellipse parabola, we know the focal curve, a curve which is passing through the focus of that one, that is called as a focal curve. So I'm taking the figure like this. Center directrix. So a point lies on the hyperbola, and joining SP and S dash P and PM and PM dash. So N is the perpendicular, PN is the perpendicular to axis. So this is a figure. So this is a figure. This is S dash is the another focus, S is the one focus, and the PN is the perpendicular to axis, that is transverse axis. This is PM, and PM dash are the perpendiculars from P to directrix L dash if you are taking. Then Z dash are the point of intersection of axis and the directrix. So then we have to difference of the focal curve. So just we have to difference of the focal curve distance of any point on the hyperbola is constant. So that is S dash P minus SP equal to constant. We have to prove that constant value. So similarly, we did that one in the ellipse also. So here let S comma S dash are foci. S comma S dash are foci. This S dash and S are foci. So ZM, this line equation, and ZMS R, Z dash M dash R, these two are directrix. So then PM, this line, PM be the perpendicular from P to X axis, and PM dash be the perpendiculars to directrix from P. So upon X axis and the two directrix respectively, two directrix and respectively. Then SP by PM equal to, we know the formula of the conic formula, that is SP by PM equal to E, and from S dash P by PM dash equal to E. So here clearly observe here only. So SP by PM value equal to E and S dash P by S PM dash value also E. So in this one we can know that this value is P if you are taking X comma Y. So Zn, sorry, here, sorry, Cn value as X and Pn value as Y. Pn value as Y. Okay, next. Please once again observe this figure. This is using the next of the solving this problem. So this is the figure. So next. So SP equal to EPM from first one. So I'm doing that SP equal to E of Zn. E of Zn. So in the previous here Zn PM value is Zn. Okay. So I'm taking here. So this is center. This is directrix. This value is, this is one point on the parabola. So then this is focus. So this value is PM. So and a perpendicular line from P to axis of X axis, then PN. This is Z. Okay, this is M. So here PM value is parallel to Zn. I'm taking Zn value. This is C value. So this is C value. I'm taking Cn value. Cn minus Cz. I'm taking Cn minus Cz, which is nothing but again Zn or Nz. Zn or Nz. Just I'm taking here Cn minus Cz. Cn minus Cz. That is Cn value is nothing but X as per the a point P lies on the X comma Y. Then the length of X axis. So then that is next. Cz is the directrix. Cz is the directrix. That's why we are proved that Cz value is A by E. Cz value is A by E. SP equal to E of X minus A by E. E of X minus A by E. Next, then just take LCM here and solve this one. Then you will get, or multiply with the E, you will get EX minus A. EX minus A. So this is equation number 1. Equation number 1. Next. Wait 1 minute. Okay, right? Next. So next. So S dash P equal to EPM dash. S dash P equal to EPM dash. So here we know value. This is S dash I'm taking. So just join this one. This is another one. S dash and the PM dash. This is a directrix, another directrix. So this is M dash. Okay. So then S dash P equal to EPM dash. Then S dash P equal to Z dash N. Here Z dash N. So here PM length. This is the PM length. 1 minute, please. Erase all. So here I'm taking like this value and this one. So this is the center. This is the directrix L dash. So here PN. Sorry, this is N value. So this is P value. This is S value. This value is A. And this value is Z. And Z dash. And this value is S dash. And this vertex is A dash. And the line perpendicular to directrix from P is, it meets M and M dash. So from this figure, so Z PM dash, so which means this value PM dash, this value. So PM dash equal to ZN, Z dash N, Z dash N. Next, that Z dash N can be written as this value is C. So CZ dash plus CN. CZ dash plus Cn. This is the total length of z dash n. Okay. Next. So then Cz dash is nothing but x, and the Cn value is, sorry, Cn value is x and Cz value is a by e. So Cz dash value is a by e. Then we'll get this formula. So this is negative value, this is positive value. So then we'll get s dash p equal to e of x plus a by e. Just solve that one. You will get s dash p equal to ex plus a, that is 2, equation number 2. So these two are passing through the focus. So then what it says, what is asked in the question, focal distances, difference between the focal distance. So that one I'm taking 2 minus 1. 2 minus 1, that is s dash p minus sp equal to ex plus a minus ex minus a, ex minus a. Then I will get this value as ex plus a minus ex value is s dash p minus sp equal to 2a. So this is the important, something is mistake there, c dash n here. Okay, so s dash p here plus value here. Okay, so then I will get this one. So then this is a 2a. So please take it once if anything mistake. So this is the important sum for IPE. So here, this is the difference of the focal curve distances of any point on the hyperbola is constant. So for that one, we are taking the as per the diagram and solving from the diagram. So this is a plus 1. So you can do this now. Notations as usual in the previous one, s equal to x square by a square minus y square by b square minus 1, and s1, s12, s11. So these are x1 by a square minus y1 by b square minus 1, s12, s12 equal to x1 x2 by a square minus y1 y2 by b square minus 1, s11 x1 square by a square minus y1 square by b square minus 1. These are the notations we are using if the tangents is there. So there is no need now, but you have to know that one for future purpose. So you may use in the MCET. Okay, so rectangular hyperbola. So rectangular hyperbola means if in a hyperbola, the length of the transverse axis. So transverse axis is nothing but the major axis. So that is length of the transverse axis is equal to length of the conjugate axis. Length of the conjugate axis. So transverse axis, conjugate axis. So this is nothing but length of this length and this length. So major axis equal to minor axis. Clearly, this is major axis equal to minor axis. In the hyperbola, we are saying transverse axis equal to length of the transverse axis equal to length of the conjugate axis. That is 2a equal to 2b. So if the values are same, so 2a equal to 2b, then we can say that hyperbola is called as a rectangular hyperbola. Rectangular hyperbola. Once again, I'm repeating that the length of the transverse axis is equal to length of the conjugate axis. That is nothing but rectangular hyperbola. Okay, now, so the hyperbola is called as a rectangular hyperbola. Its equation is clearly this value is nothing but I'm taking x square by a square minus y square by b square is any hyperbola. So but I'm substituting b as a, so that is a square equal to 1. Just solve this one, you will get x square minus y square equal to a square, where a equal to b. Otherwise you will get x square minus y square equal to b square also. So this is called as rectangular hyperbola. So then in this case we have one very short answer for IPE, that is this one. What is the question in the IPE? Define the rectangular hyperbola and find its eccentricity. Define the rectangular hyperbola and find its eccentricity is the question in IPE. So very short answers for this one. So in this case, we know the value a equal to b, a equal to b, e square equal to a square plus b square by a square, e square equal to a square plus b square by a square. Why? The because of these both are equal here, then we can substitute b as a or a as b. Then I'm taking is a b as a square plus a square by a square. The numerator value is 2a square. The numerator value is 2a square by denominator value is a square. Then just you have to cancel this one, a square a square. Then you will get e square equal to 2. So this one, e square equal to 2. So then e value is e value. What is the e value? This value. Okay. If e square equal to 2, then e value is nothing but root 2. Root 2. The eccentricity of a rectangular hyperbola is root 2. So clearly this is an important question for IPE, and that once again I'm repeating, rectangular hyperbola. So rectangular hyperbola, which is nothing but length of the transverse axis is equal to length of the conjugate axis, and its eccentricity is e equal to root 2. E equal to root 2. Okay. Next. So auxiliary circle. So we are discussed, this is also auxiliary circle in the ellipse. That is nothing but the length of the major axis is equal to diameter of the circle. That is called as the auxiliary circle. So length of the major axis is equal to the diameter of the circle. Then it is called as auxiliary circle. So similarly here, so we can define auxiliary circle. The circle described on the transverse axis of hyperbola as a diameter is called the auxiliary circle of the hyperbola. So which is nothing but transverse length of the transverse axis is equal to the diameter of the circle. Then that is called as auxiliary circle. Figure like this. So here this value is the length of the transverse axis is equal to diameter of the this circle. Okay, this is, and also here this is a comma 0, this is minus a comma 0. Then what is the radius of the circle, which is a? Radius of the circle, auxiliary circle radius is a. Okay, next. So a circle cuts the rectangular hyperbola xy equal to 1 in the points x r comma y r equal to 1 2 3 4. Prove that x1 x2 x3 x4 equal to y1 y2 y3 y4 equal to 1. So a circle cuts a rectangular hyperbola. Circle cutting the rectangular hyperbola. Then like this. So then this is the figure. Okay, now circle, I'm taking circle equation as like this with the radius a, that is x square plus y square equal to a square. Then I'm taking, since t comma 1 by t, where t is not equal to 0, lies on x y equal to 1. X y equal to 1. Here given that x y equal to 1, that's why I'm taking t value, x value as t, y value as 1 by t. So then just substituting the points of intersection of the circle and the hyperbola are given by, just you have to substitute the this point on this equation. Then you will get t square plus 1 by t square equal to a square. T square plus 1 by t square equal to a square. Then just solve this one. You will get t power 4 plus 1 by t square equal to a square. Then this can be written as biquadratic equation, which is t power 4 minus a square t square plus 1. This is a biquadratic equation. So this is like this: t power 4 plus 0 times of t power 3 minus a square t square 0 plus 0 times of t plus 1 equal to 0. So this is the biquadratic equation. So we know the what is the theory of equations? Roots. How can you find the roots of the equations? If alpha, beta, gamma are the roots of the equation, if alpha, comma, beta, comma, delta are the roots of the equation, then that's why we are solving here. That is, so this is a biquadratic equation: x power 4 minus s1 x cube plus s2 x square minus s3 x plus s4 equal to 0. Then then the product of the roots is nothing but s4. Product of the roots I'm taking only is asking in the question is nothing but x1 x2 y1 x1 x2 x3 x4. So I'm taking this one S4 equal to constant by coefficient of t power 4. This is a rule. So then, so here in the previous T1, T2, T3, T4 equal to 4. Constant term. So constant term value is T1, T2, T3, T4 equal to 1. Why that? Because of here in the question he mentioned that x r y r equal to 1 2 3 4. Just you have to take substitute x r value 1 1 2 3 4. So that's why you will get this one S4 value, and similarly XR where this is nothing but this one. So and so when x1 x2 x3 x4 equal to t1 t2 t3 t4, as per the we are taking in the point of intersection of circle and the hyperbola, then we'll get t1 t2 t3 equal to 1. Similarly y1 y2 y3 equal to 1 by t1 t2 t3 t4, which is nothing but 1 by 1. As usually this value is 1 by 1 is nothing but 1. Okay, next, so parametric equations. So then the diagram as follows. So here in the auxiliary circle, we know the auxiliary circle, that is nothing but length of circle. So length of the transverse axis is equal to diameter of the circle. So this is the figure which is I'm taking. So this angle theta. So please observe this figure. So here this is angle theta and the radius is a tangent from M to circle equation. MQ is a tangent. MQ is a tangent and the QCM or MCQ is the triangle, and a point P lies on the hyperbola. Okay, then we can find the parametric equations for this one. Then let the equations of the hyperbola s equal to 0. Then the equation of the auxiliary circle is nothing but this one. Auxiliary circle, I am taking x square plus y square equal to a square. So then Px, Yb lies on the hyperbola, then C be the center and M be the projection of P on the x-axis, on the transverse axis. Then so draw QM be the auxiliary circle. Draw a tangent. Tangent means it touches only one point, that is QM. So onto the auxiliary circle from M. So then now, so MCQ, triangle MCQ equal to theta, we are taking in the figure, that is x coordinate of the P is nothing but P equal to CM equal to x equal to a secant theta. So that's why here, see here, this value is, okay, I'm taking this diagram like this. So this value is C, okay, and this value is M. Is it M? No, this value is, sorry, this value is Q and this value is M. So theta. So from this one you can find, so CQ length of CQ is A. Length of CQ is A. So why? Because of the radius of the circle, auxiliary circle is A. Then so we have to find the cos theta or secant theta. I'm finding secant theta. Secant theta is nothing but hypotenuse by adjacent. Hypotenuse by adjacent. That's why we can get x PM P equal to CM and P, then x equal to a secant theta. A secant theta. Substituting this value of x in x square by a square plus y square by b square equal to 1, we have, that is just x value is, you have substituting here a square of secant square theta by a square minus y square by b square equal to 1. Then so then this value is, this is minus, so then y square by b square equal to y square by b square equal to, this will be cancelled, and you have to take this is right side, this value left side, secant square theta minus 1 equal to tan square theta. We know the formula, that one, from the secant square theta minus tan square theta equal to 1, and the y square by b square value right hand side, and the reverse the equation, you will get y square by b square equal to tan square theta. Then just you have to take this b square value to right side, you will get y square value as b square of tan square theta, b square of tan square theta. Then this value is if for solving for y, you will get plus or minus b tan theta. Y value plus or minus b tan theta. Then p can be expressed as a secant theta, b tan theta. A secant theta, b tan theta. This is the parametric form for the hyperbola. But ellipse is nothing but a cos theta, comma b sin theta is the parametric form. And here hyperbola, a secant theta, b tan theta. So remember it. And a conjugate hyperbola. So in the previous we defined that one rectangular hyperbola. Now we are defining conjugate hyperbola. That is the hyperbola whose transverse and conjugate axis eyes are respectively conjugate and the transverse axis. Clearly, in the rectangular hyperbola, length of the transverse axis is equal to length of the conjugate axis. Here, clearly the hyperbola whose transverse axis and conjugate axis is are respectively conjugate axis and the transverse axis, which is nothing but conjugate axis may transverse axis may conjugate axis. That is called as a conjugate hyperbola. So of the given hyperbola is called the conjugate hyperbola of the given hyperbola. So then the equation of the hyperbola conjugate to S.
Balakrishnan sir,
Ma'am.
kindly repeat the definition, sir, once again, please. Conjugate
Okay.
hyperbola.
Okay, right. The hyperbola whose transverse and conjugate axis are respectively conjugate and the transverse axis. So which means the transverse axis is nothing but conjugate axis, or conjugate axis is nothing but transverse axis. That is the conjugate
hyperbola
of the given hyperbola. So that is nothing but a conjugate hyperbola. So then now if you are taking x square by a square, x square by a square plus y square by b square minus 1. So here, sorry, this is minus. So hyperbola equation is x square by a square minus y square by b square equal to 1. Then the equation, this will be I'm taking the hyperbola, and this value is nothing but conjugate hyperbola with respect to this s. So here also this is minus. So this is x square by a square minus y square by b square minus 1 equal to 0. Then the conjugate to this hyperbola is nothing but s dash. I'm taking x square by a square minus y square by b square plus 1 equal to 0. So next, this is value. So this is minus, students. Okay, if you check, please check it. And for x square by a square minus y square by b square equal to 1, the transverse axis is nothing but its length is 2a. Transverse axis, what is x axis? Transverse axis is x axis and the length is 2a. If the conjugate axis lies on the y axis and its length is 2b. Similarly, here x square by a square minus y square by b square equal to minus 1. Then this is the conjugate axis, conjugate hyperbola to the given. We are taking that one. Then the transverse axis is along x axis. Its length is 2b. The conjugate axis lies on y axis. Its length is 2a. Just reverse. Okay. So once again, I'm repeating x square by a square minus y square by b square equal to 1. The transverse axis lies along x axis and its length is 2a. And if the conjugate axis lies y axis and its length is 2b. Similarly, transverse axis lies on x axis. So that is 2b. Conjugate axis is 2a. So here, next one figure is there. What is it? Here, just this is a hyperbolas, conjugate hyperbolas. So this is the figure. So next, the hyperbola s dash equal to 0 is called the conjugate hyperbola of s equal to 0. As s equal to 0 is called the conjugate hyperbola of s dash equal to 0. Here clearly says that if the hyperbola s dash equal is called the conjugate hyperbola for s equal to 0. Similarly, s equal to 0 is the conjugate for s dash equal to 0. Interchanging. Thus, each is called the conjugate of each other. Then conjugate hyperbolas s dash s equal to 0 is a hyperbola, then S dash is the conjugate hyperbola for S. If S dash equal to 0 is a hyperbola, then S equal to 0 is the conjugate hyperbola for that one. So let this value x square by a square minus y square by b square minus 1 equal to 0. So then equal to 0 be the hyperbola, and this is the minus 1. S dash value is x square by a square minus y square by b square plus 1 equal to 0. B it's a conjugate hyperbola. Then so this is the most important for IP, very short answer. So if E even are the eccentricity of hyperbola and its conjugate hyperbola. So what is saying that E even are the eccentricities of hyperbola and its conjugate hyperbola. In the says that hyperbola eccentricity is E we are taking, and the conjugate hyperbola eccentricity is E1. Then we can prove that A square, prove that 1 by E square plus 1 by E1 square equal to 1. 1 by E square plus 1 by E1 square equal to 1. Then solution for that one, I'm doing this, I'm taking this one. This is E be the eccentricity for S equal to 0. Let E be the eccentricity of the hyperbola, which is S equal to x square by a square minus y square by b square minus 1 equal to 0 is E equal to under root of a square plus b square by a square. So where a is greater than b. Okay. Similarly, so and E1 be the eccentricity of its conjugate hyperbola. So that is x square by a square minus y square by b square plus 1 equal to 0. Then E1, we are taking E1, E square plus b square by b square. So which is a is less than b. Here, where is this? Okay. So then this is a is greater than b and this is a is less than b. Clearly, that is the difference between the hyperbola and the conjugate hyperbola. Then E equal to under root of a square plus b square by a square is the hyperbola eccentricity, and E1 equal to under root of a square plus b square by b square is the eccentricity of the conjugate hyperbola. So then we have to prove that 1 by E square plus 1 by E1 square. So we have to substitute here E value as this one. So squaring means you have to do square here. You will get this values, root gets cancelled. Root gets cancelled. You will get a square plus b square by a square and similarly here 1 by E1 square, and also you have to square here. You will get cancel as a root. Then you will get a square plus b square, a square plus b square by b square. So just this is 1 by, this is 1 plus this is 1 by, sorry. So this is 1 by and this is 1 this one value, this is 1 value. Just here clearly this is take into numerator and this will be the denominator as it is. Similarly this is I will get a square by a square plus b square. So here a square by, sorry, once again 1 by a square plus b square by a square. Here we have this one. So I'm taking this one to numerator. Similarly in the one, then I will get that value is a square by a square plus b square, a square plus b square. So similarly this is for the hyperbola eccentricity, and the next one is conjugate hyperbola. Will get similarly in this way, b square by a square plus b square, a square plus b square. Then this value a square plus b square by a square plus b square, which is equal to 1, which is equal to 1. And also from this one we can do one or two problems, that is using this formula 1 by e square equal to 1 minus 1 by e1 square, e1 square. So in this type of questions will be asked May. So if gives the hyperbola or conjugate hyperbola eccentricity and find the other ones, So this is the question. And if I'm repeating once, if E1 are the eccentricity of hyperbola and its conjugate hyperbola, then we have to prove that 1 by e square plus 1 by e1 square equal to 1. So eccentricity of hyperbola is nothing but E equal to under root of a square plus b square by a square, and the eccentricity of conjugate hyperbola, which is nothing but E1 we are taking, that is under root of a square plus b square by b square. Just add this, add the that reciprocals, that 1 by e square plus 1 by e1 square, then substitute and solve. You will get 1 by e square plus 1 by e1 square as 1. Okay, so this is the assignment for today. So here, 1 second. So here, find the equation of the hyperbola whose foci are 4, 2, 8, 2, and the eccentricity is 2. So we given that foci values here. If your s value is here, s dash value there, and s value is there. So distance, you have to find the distance between distance between the foci. You will get 2ae equation and substitute the e value is here, and you will get a value. Then from that a value and e value, you will get b value. Substitute the required equation, that is x square by a square minus y square by b square equal to 1 if a is greater than b and b is greater than a. So then find the equation of the hyperbola. Length of the transverse axis. Length of the transverse axis is 2a, whose vertex bisects between the center and focus. I think this is explained in the class. Okay, no need this one. So if the eccentricity of the hyperbola is 5 by 4, so previously question. So eccentricity of hyperbola and the conjugate hyperbola. So eccentricity of a hyperbola is 5 by 4. Then find the eccentricity of its conjugate hyperbola. Just e value is 5 by 4. You have to find e1 value. Okay, next, these two are two lines, that is 3x minus 4y minus 12 equal to 0, and 3x plus 4y minus 12 equal to 0 meets the an hyperbola on a hyperbola s equal to 0. Then find eccentricity of the hyperbola. Just you have to, this is equation number 1, this is equation number 2. So these two lines are meet on a hyperbola, which means what is the point of intersection point of these two? You will get a point. That point lies on the hyperbola. So then you will get one hyperbola equation. Then you will easily find the eccentricity of that equation. And now the fifth question is to find the equation of the hyperbola whose foci is given that, and the transverse axis. The first one, transverse axis. Okay, this is different one. So distance between the foci and the transverse axis is given that. Then you will get 2ae, the relation between the 2ae and the a. Then you will get a value, b value, a value. From that one ae, you will get b value. Just substitute in the equation. This is the assignment. And various forms of hyperbola. Various forms of hyperbola. So this is the various forms of hyperbola. So we can. So this is if a hyperbola. Sorry, where is it? Okay, right. Yeah. So this is a hyperbola. We are taking hyperbola. This is conjugate hyperbola. So x square by a square minus y square by b square minus 1 equal to 0. So which is a is greater than b. Then transverse axis along x axis and y value should be 0. Length of the transverse axis is 2a. We know that. Then the conjugate axis is nothing but minor axis. That's why this is lies on the y axis, and the x coordinate should be 0. Length of the conjugate axis is 2b. Length of the conjugate axis is 2b. And the coordinates of the center is nothing but 0, 0 from the here. And coordinates of foci. Foci we are finding that one. Find that one. That is x equal to. So foci value ae, 0 in the first standard form of parabola. So that is 1 plus 2. We did that one. We did there. So we'll get x equal to plus or minus ae, 0. So equation of directrix in the same one, 2 minus 1, we'll get x equal to plus or minus a by e. So eccentricity. So from the b square equal to a square of e square minus 1, we'll get a square e value as under root of a square plus b square by a square. This is the hyperbola. If it's a conjugate hyperbola, which means major axis, transverse axis on the conjugate axis and the transverse axis. That is, so conjugate axis, conjugate hyperbola. Then this value, where is this? Okay, so equation may be changed. This is only plus 1. So here transverse axis is along x axis. Transverse axis is along x axis. Sorry, y axis, that is x equal to 0. So there is no x coordinate. So then length of the transverse axis is 2b. Similarly, conjugate axis of x axis, conjugate axis is along x axis, y equal to 0. Length of the conjugate axis is 2a, and the center is 0, 0. And we have to solve. We can solve as like this in the standard form. Then coordinates of the foci is nothing but 0 comma plus or minus be, and the directrix is y equal to plus or minus b by e, and the eccentricity is under root of a square plus b square by b square, where a is less than b. These are the hyperbola and the conjugate hyperbola, where the center at 0 comma 0, center at 0 comma 0. If the center not at 0 comma 0, if it is an h comma k, if the center h comma k, we can various forms of hyperbola where center not at origin, not at origin. So center where we are taking h comma k, I'm taking h comma k, so which is nothing but here. So this is 0 comma 0, and I'm taking hyperbola here. So this center transform to h comma k here. This is 0 comma 0, this is h comma k. So that's why. So here transverse axis is along y equal to k, which means, so this is y equal to k. This is a transverse axis of the hyperbola, but the center is here. So center is here. This is the transverse axis of the hyperbola. Then I'm taking y equal to k, and the length of the transverse axis is nothing but this is 2a. Similarly, conjugate axis is along x equal to k. This is x value. This is the x axis and x equal to h, and the length of the conjugate axis is 2b, and the center is nothing but h comma k if the coordinates of the foci is nothing but h plus or minus ae comma k. So in the previous one we know the value. This is value 0 and this value is 0. Why? Because of these values are 2 zeros. Just you have to substitute there h plus or minus ae comma k. Then equation of the directrix, in that one also this is 0 plus or minus a by e, that is x equal to equation of the directrix x equal to h plus or minus a by e, and the eccentricity is same as it is under root of a square plus b square by a square. Similarly, this is a hyperbola, and conjugate hyperbola for this one is nothing but here x minus h whole square by a square minus y minus k whole square by b square equal to -1. Transverse axis is along x equal to h, x equal to h. So this value is different. So a is greater than b and a is less than b. That's why we are taking transverse axis is along x equal to h. Length of the transverse axis is 2b. Conjugate axis is along y equal to k. Similarly, as shown in the hyperbola. So that is different. So then coordinates of the length of the conjugate axis is 2a, and the coordinates of the center is h comma k. Coordinates of the foci is h comma k plus or minus b. Equation of the directrix y equal to k plus or minus b by e. So these are same like this one, these two, and the eccentricity is nothing but same as usually as per the conjugate hyperbola, e dash equal to under root of a square plus b square by b square. Okay. So hyperbola, conjugate hyperbola. Thank you, madam. Thank you, sir. This is the class today. Hello. Hello.
Thank you, sir.
Thank you, sir.
Okay, right.
Okay. Post changes.